Hello guys, welcome to Fun with Nomenclature, in which you will learn how to name and draw structural formulas for hydrocarbons, also that distinguish the types of hydrocarbons and functional groups within a structure. Believe me, it's too fun, and if it isn't fun, we will do fun for you. So let's begin it. First, I will let you a little introduction about what we're going to see in this video. First, we have the UPAC. But what is a UPAC? Well, it's an acronym for Information Union of Pure and Applied Chemistry. It is recognized authority for chemical standards of nomenclature, measurements, and atomic mass values. Hurrah for UPAC! Long life for UPAC! But what I need to learn about nomenclature? What is the function of learn this? Well, chemists come from all over the world, and these such may have their own names for certain compounds. With the rules to name hydrocarbons, there is no confusion, and the best minds in the world we can together better and create more incredible and useful things. And the rules serve to have an order, and everybody found the same name to the hydrocarbons. I will lead you with a pair of friends that will teach you how to name and draw these hydrocarbons. So let's begin with the fun. Hydrocarbons. A hydrocarbon is an organic compound such as benzene, methane, or ethyl, made of two elements of carbons and hydrogen and found in coal, crude oil, natural gas, and plant life. Hydrocarbons are used as fuels, solvents, as raw materials for numerous products. The main classification based on types of bonds involved in the structure. Hydrocarbons from which one hydrogen atoms has been removed are functional groups called hydrocarbons. Aromatic hydrocarbons are alkenes, alkene, cycloalkene, alkene based on compounds are different types of hydrocarbons. The classification for hydrocarbons defined by UPAC nomenclature of organic chemistry are as follows. Saturated hydrocarbons, or alkanes, are the simplest of the hydrocarbon species. They are composed entirely of single bonds and are saturated with hydrogen. The general formula for saturated hydrocarbons is CnH2n plus 2. Unsaturated hydrocarbons have one or more double or triple bonds between carbon atoms. Those with double bonds are called alkenes. Those with the one double bond have the formula CnH2n. Those containing triple bonds are called alkenes, with general formula is CnH2n half 2. Cycloalkenes. What about cycloalkenes? They are hydrocarbons containing one or more carbon rings to which hydrogen atoms are attached. The general formula for a saturated hydrocarbon containing one ring is CnH2n. Aromatic hydrocarbons, also known as arenes, are hydrocarbons that have at least one aromatic ring. What is an alkane? Alkanes are a class of hydrocarbon in which the atoms are connected by a single bond. The steps to name them, based in UPAC systems, has many steps. The first one, write the alkane name of the longest chain of carbon atoms. In this alkane, the longest chain has 5 carbon atoms, in which is pentane. 1, 2, 3, 4, and 5. So this is a pentane. And the second step is number the carbon atoms starting from the end neither a substituent. Number the chain from 1 to 5, starting from at the end near the branch of methyl. Once you start numbering, continue in the same direction. It says 1, 2, 3, 4, 5, because it's a pentane. So the methyl is in the second carbon, right here. So the third step, give the location and name of each substituent in alphabetical order as a prefix to the name of the main chain. It says this is a methyl, so it will be 2-methyl. Fourth step. The name is formed with a number or numbers of the carbon when the alkyl group is found, hyphen the name of this or this, and the name of the main chain. So it will say in this example 2-methyl pentane. We will show you 2 more examples applying the given steps. In this one, we have 6 carbons, so it will be an hexane. The next step is number 8. 1, 2, 1, 2, 3, 4, 5, and 6. So the carbon number 2 we have a methyl, but also in the carbon 6. And in the carbon 5, the carbon 4 we have a methyl and an ethyl. So it will be 4-ethyl 2-methyl hexane because has 6 carbons. In the next example, we have an heptane because has 7 carbons. 1, 2, 3, 4, 5, 6, 7. So in this example, we have a methyl in the carbon number 2, carbon number 3, carbon number 4. The correct name will be 4-ethyl 2, 3, 4 3-methyl heptane. The other way is draw the given name of the alkane. If you have the name only, follow these steps to obtain the formula. Given name. In this case, we have a 2,3-dimethyl butane. The first step is draw the main chain of carbon atoms for butane. So butane it has 4 carbon atoms, so it will be carbon, carbon, carbon. The first part of the name indicates 2 methyl groups, one on carbon 2 and one on carbon 3. So it will be in the carbon 2 it will have a methyl, and the carbon 3 also it should be a methyl. The third step, add the correct number of hydrogen atoms to give the bonds to HC atoms. So 8 carbon atoms it will form 4 bonds. So we need to complete the bonds. So it will be 2,3-dimethyl butane. We have 2 more examples showing the same way to build the formula for 2 different names. If we have the name 3-ethyl 2-methyl octane, it says that we have 8 carbons. So after draw the 8 carbons, we must number it 1, 2, 3, 4, 5, 6, 7, and 8. So the name tells us that the carbon 2 has a methyl, also the carbon 3 has a methyl and ethyl. We must write it. And then complete the alkene. Are families of hydrocarbons that contain one or more carbon. Double bond that forms when adjacent carbon atoms share 2 pairs of valence electrons. These steps to name them based in UPAC system is: the first step, name the longest carbon chain that contains the double bond. There are 5 carbon atoms in the longest carbon chain containing the double bond, replacing the carbon corresponding alkane ending with the any given pentane, ane. So in this example we have pentane, which have 5 carbon atoms. So the double bond is over here. The second step, number the carbon chain from the end nearer to the double bond. The number of the first carbon in the double bond is used to give the location of the double bond. Alkene with 2 carbons do not need number. For example, the double bond in ethane or propane must be between carbon 1 and carbon 2. Like the example we have the chain numbered from right to left. It says 1, 2, 3, 4, and 5. The bond is between the carbon 2 and the carbon 3. So it will be 2-alpha pentane. The third step, give the location and name of each substituent alphabetical order as a prefix to the alkane name. The methyl group is located on carbon 4, so the name will be 4-alpha methyl, alpha 2-alpha pentane. Look at the example is 1, 2, 3, 4, which the methyl is here in the 4 carbon, and in the carbon 2 is the double bond. So we have 5 carbons in the main chain, so it will be 4-alpha methyl, alpha 2-alpha pentane. There are other 2 examples that show the steps to create the formulas to the next name. In this example, we have 3,4-alpha dimethyl, alpha 2-alpha hexane. So in this chain, in the main chain, we have 6 carbons. And also the name gives us more information about where the double bond is. So it says that the double bond is between the carbon 2 and the carbon 3. So first of all, we can see that the main chain is numerated from left to right. So 1 and 2. In the carbon 2, we have the double bond. Also, the name gives us more information about where the methyls are. It says we have a dimethyl, so we have 2 methyls. So we have these methyls in the carbon 3 and the carbon 4. So finally, we have 3,4-alpha dimethyl, alpha 2-alpha hexane. And the other example that we have here is 3-alpha methyl, alpha 4 methyl, alpha 2,4-alpha heptane. So the name gives us that we have 7 carbons in the main chain. As we can see, we have the carbon main chain, and we have the double bond in the 2 carbon, and also we have another double bond in the 4 carbon, and we have a methyl, an ethyl in the 3 carbon, and in the 4 carbon we have an ethyl. So the name will be 3-alpha ethyl, because the ethyl is on the 3rd carbon, 4-alpha methyl, because the methyl, we have a methyl in the carbon number 4. And the what about the double bonds? We have the double bonds in the carbon 2 and the carbon 4. So it will be alpha 2,4-alpha heptane, because we have 7 carbon atoms. Now, if you already have the name of the alkene and you need to know the formula, these steps will help you to build the formula. The first step, draw the main chain of carbon atoms. Give name. In this example, the name is 3-ethyl alpha 5-methyl alpha 4-alpha octane. For the hexane, we need to put 8 carbon atoms in the main chain. So we should draw 8 carbons. And then we need to put the double bond where the name indicates. In this case, the name indicates that the double bond is in the carbon atom called 4. So it will be C, alpha C, alpha C, alpha C, and a double bond C, alpha C, alpha C, and alpha C. In the number of the chain, place the substituents on the carbons indicated by the numbers. Our formula I already told, and we have ethyl in the carbon number 3 and methyl in the carbon number 3 too, and another methyl in the carbon number 5. So then finally we need to add the correct number of hydrogen atoms to give 4 bonds to each C atom. So in the carbon number 3, we need 3 more, so it will be CH3. In the carbon number 2, originally we have 2 bonds, so we need 2 more bonds. In the carbon number 3, we have a bond, we have 4 bonds, so it's completely. And also with carbon 4, the carbon number 5 has a methyl oxide, and to the right side we have a carbon, so we need in the left side 2 more bonds. And the carbon 6 needs 2 more hydrogens, the 7 needs 2 more hydrogens too, but the 8 needs 3 carbons because only has an allies with the 7 carbon. With these steps we can do other 2 examples of alkenes to know better how can draw the formula of the given name. If we have the name 3-methyl-2-butane, so we need first of all write 4 carbons because it is a butane, and then write the double bond, and after that complete the bonds, and then place the methyl in the 3rd carbon, which in this is located, and then complete with hydrogens the missed bonds. So in the 1st carbon it will need 3 more hydrogens. In the carbon 2 we need only 1 hydrogen. In the carbon 3 we have in the left side 2 bonds, and in the right side 1 bond, but the 4 carbon needs 3 hydrogens more to complete the 4 bonds. In the next example we have the name 2-methyl-3,5-dimethyl, 2-hexane. So in this case we have 6 carbons in the main chain, and after that we need put the double bond, which is located in the 2nd carbon, and after that we complete the bonds, and then place the methyls and the ethyl. We have an ethyl in the 2nd carbon and 2 methyls. The first one is located in the 3rd carbon, and the second one is on the carbon number 5. So after that we need to complete the carbons with H3, and the 1st carbon is H3, the 2nd carbon is completely, the 3rd carbon also is completely, the 4th carbon needs 2 more hydrogens to complete their 4 bonds, and the 5th carbon needs only 1 hydrogen to be completely, and the 6th carbon needs 3 more hydrogens to be completely. So this is all for alkenes. Alkenes are families of hydrocarbons that contains 1 or more carbon triple bond that forms when adjacent carbon atoms share 3 pairs of valence electrons. The steps to name them based in UPAC system is the first step. Name the longest carbon chain that contains a triple bond. In this example, there are carbon atoms in the longest carbon chain containing the double bond. Replacing the corresponding alkane ending with -ine gives pentyne. So in this example we have 5 carbon atoms, but the double bond, the triple bond, is located in the carbon number 3. So it will be pentane. The second step, number the carbon chain from the end near the triple bond. The number of the first carbon in the triple bond is used to give the location of the triple bond. Alkene with the 3 carbons do not need number. So first of all, we need to numerate the chain from the nearest triple bond. So it will be from right to left. It will be 1, 2, 3, 4, and 5. So the name will be 2,2-pentane. Like this example. Give the location and name of each substituent alphabetical order as a prefix to the alkane name. This is the 3rd step. the methyl group is located on carbon number 4. So it will be 4-halfene methyl halfene 2-halfene pentane. There are other two examples that show the steps to create the formula to the next name. In this example, we have 4,5-halfene dimethyl halfene 2-halfene hexane. So it will be from left to right, 1, 2, 3, 4, 5, and 6. It will be in the carbon 2, it will be the bond, which the name tells us, and the carbon 4 and 5, it will be 2 methyl in each corresponding dimethyl, so it will be here 4 and 5. And finally, the correct name will be 6-halfene methyl halfene 7-halfene methyl halfene 2,4-halfene octane, because the main chain carbon has 8 carbons, so it will be octane. Now, if you already have the name of the alkene and you need to know the formula, this step will help you to build the formula. First step, draw the main chain of carbon atoms. Give name 3-ethyl, given name 3-halfene ethyl halfene 6-halfene methyl halfene 4-halfene octane. For the hexane, we need to put 8 carbon atoms in the main chain. Over here, 1, 2, 3, 4, 5, 6, 7, and 8. The second step, put the triple bond where the name indicates. In this case, the name indicates that the triple bond is in the carbon atom called 4. So 1, 2, 3, 4. Here we have the triple bond, and after that we can continue with our carbons 5, 6, 7, and 8. The third step, number the chain that places the substituents on the carbons indicated by the numbers. So it will be wherever that we choose, if it's left to right or right to left, we need to numerate. Let's choose left to right. We have 1, 2, 3, 4, 5, 6, 7, and 8. So in the carbon tree, the formulas tell us that we need ethyl and methyl. And in the carbon number 6, we have a methyl. The fourth step, add the correct number of hydrogen atoms to give 4 bonds to HC atom. So the first carbon needs 3 more bonds, so we will put 3 hydrogen more. The second carbon needs 2 hydrogens. The 3 doesn't need more bonds, so only the third carbon only needs 1 bond. Beautiful benzene consists of a ring of 6 carbon atoms with 1 hydrogen atoms to each carbon. Because many compounds maintain benzene has foreground odors, the family of benzene compounds became known as aromatic compounds. The first step to name an aromatic is number if the direction of the give the lowest zeros, the number and the name alphabetically. In this case, the used numbers are 1, 2, and 4, that is equal to 7. The second step, give the name in where each one is located and add a benzene alphabetically. We have a methyl in number 1, a chloro in number 2, and a bromo in number 4. So it will be 4-halfene bromo, halfene 2, halfene chloro, halfene 1, halfene methyl benzene. But when we start with methyl chain, the name benzene for toluene, so the name also is correct of this form. 4-halfene bromo, halfene 2, halfene chlorotoluene. And to practice aromatic compound, we have 2 more examples. In this example, if we named starting with the first chloro, it will be 1 for the chloro opside, and then we named to the right, so it will be 1, 2, 3, 4, 5, and 6. It will be 1, 3, 5 halfene chlorobenzene. And the next example, we have methyl 2 bromo and a chloro. If we numerate from the methyl to the left side, it will be 1 chloro, 2 bromo, 3, 4 chloro, 5, and 6. So it will be 2,6 dibromo helphen 4 helphen chlorotoluene. But if you have only the name and need to draw the formula of structure, these are the steps. First step, draw the representative structure of the aromatics compounds. So here we have an hexagon, and then locate the groups starting like you want. If we have the name 2 helphen ethyltoluene, we need to start with the methyl in any vertex. It's easier to make aromatics than alkanes, alkenes, and alkene, because always we have the same structure. There are 2 examples more. In this example, we have 1 helphen bromo helphen 2 helphen chlorobenzene. So this is the structure for this formula. In the second formula, we have 2 helphen bromo helphen 3 helphen chlorotoluene. So we have this. It will be more easy if we start with chlorine, with chloro. So it will be 1 chloro, 2 bromo, 3 methyl, 4, 5, and 6. So this is the formula. Well, I hope that you enjoyed. What is a hydrocarbon derivate? Organic compounds are derived in 2 main classes, hydrocarbons and hydrocarbon derivatives. Hydrocarbon derivatives are molecule compounds of carbon and at least one other element that is not hydrogen. Hydrogen derivatives are formed when there is a substitution of a functional group of the one or more of these positions. Exists hydrocarbon derivative whose functional group involves a heteroatom single bonded to a carbon atom, halogenated hydrocarbons, alcohols, ethers, aldehydes, and amines. Also, derivative whose functional group contains a carbon-oxygen double bond, aldehydes, ketones, carboxyl acids, esters, and mides. In this table, we show a simple table where we include the main structure for the functional groups. Related to the hydrocarbon derivatives include 2 examples for each and highlight where the main structure of the function group is.